Personal finance practice problem using Excel. Rule of 72 and running balance calculation problem number 2. Prepare to get financially fit by practicing personal finance. Here we are in our Excel worksheet. If you have access to the Excel worksheet, would like to follow along, note that we're in the practice tab as opposed to the example tab. The example tab, in essence, being an answer key. We have the information on the left-hand side, going to populate that into the blue area on the right-hand side. This is the second of a similar problem. Therefore, we're going to pick up the speed a little bit in the Excel worksheet. So if you want to go to a problem that might be a little bit slower as we work through it in Excel, take a look at the prior problem that is of a similar nature. We'll still try to keep it relatively slow as we go through. We have the yearly earnings percent of an investment is 12%. So we are assuming we have some kind of investment. That could be stocks, that could be some bonds, that could be a savings account or a CD or something like that, which we're going to make the assumption is going to be increasing annually at 12%. Then ask the question of how long it will take for the investment to double. So note what we don't have until we get to this point down here is what the investment actually is. So you could ask this question. You might be asked in like a test question, how long it would take to double without actually having the investment. And sometimes if you were to be asked that, it's useful to then think of an investment like $1,000 or $100 or $2,000, whatever the starting point might be, to help you to kind of visualize what's actually happening. For most people, it makes it a bit more concrete. But for the first rule, the rule of 72, we're gonna not be using the investment amount down here and just think about any kind of thing that's going to be appreciating. How long would it take to double if the rate of return was at the 12%? So the rule of 72 is an estimating rule. It's a shortcut kind of rule. It can be useful if you have to be doing something on the go or in pressure, but also, it's limited, and we'll talk, of course, about those limitations and other ways you could do a similar calculation that's more flexible and possibly some that will give you more information in the future. So the rule of 72 is simply going to be, we're going to take the rule of 72, I'm going to call it. Note that I'm going to start to build our table whenever we do these calculations, even though this is a basic calculation, to get an idea and feel for entering this into an Excel sheet, and also pulling our data from a data input tab on the left whenever possible. That allows us to run multiple scenarios. So I'm going to start off with a hard-coded number, just 72, because it's the rule of 72. We'll type in here. And then I'm going to pick up the rate down below. We'll type in the rate. Now the rate is going to be, I'm going to pull that into the inner column because we're going to make a little adjustment to it. We have the rate at the 12% up top, which you could simply type in here, but we would like to take the rate from our data tab on the left-hand side. Therefore, I'm going to say equals, so I can pull the rate over here from this cell by simply clicking on it. There's B2 in the rate. I'm going to say enter. It shows 0 because the cell has no decimals in it. It's not actually 0, but it shows 0. We're going to go to the Home tab, Number Group, and we could add a couple decimals. That would give us our 0.12, or we could make it a percent by go to the Number Group and percenting it, making it a percent. I call that percentifying it, which is not a formal term. And then we can go down here, and we're just going to take that and multiply it times 100% because the rule of 72 really isn't a percent. We want to make that percent into just a number, which is 12. So it's just going to be 12 instead of 0.12 or 12%. And so I'm going to do that by going to the fonts group, underline this cell, and then I'll just multiply it out. I'm going to put that in the outer column. So we're simply going to be taking the 72 divided by 12. And so we're going to say this will equal then the 12%, which is in cell E3, times the asterisk on the keyboard, the 100. That will then give us simply 12. And then I'm going to underline it, font group and underline. And this is going to be the years to double, which is going to be equal to the 72 divided by the 12, which is going to be F2 divided by F5. And there we have it. Now I'm going to add a couple decimals just in case it's not even. I think it is even in this case. So we're going to go number group down here, add a couple decimals. So we're simply at 6. So there we have it. And no, that's an estimated number. It's not exact, but that gives you a nice estimate. And obviously we did this in a formal fashion. You could just say, okay, it's the percent, which I'm going to make into just a number, which is not 0.12, but 12. when we're using the rule of 72, and then I take 72 divided by whatever the interest rate is in like a number format instead of a decimal or percent format to get to the years that it would take to double. Let's go ahead and prove that in one sense and give us a little bit more information by doing a running balance calculation. Now, these running balance calculations are really useful to be doing. So to do this, let's hide some cells. I'd like to see my data on the left-hand side right next to these cells that I'm going to be working with on the right-hand side. So I'd like to hide columns D over to whatever this is G over here. I'm going to put my cursor on D dropdown, left click, drag over to G. And you're not required to do this, by the way, but just to practice hiding cells to maneuver around your Excel worksheet, right click on that selected area and hide it. Now we got our new data, our new table right next to our data so we can kind of work with it. So what I want to do here is just set up our table. This is a running balance table, very useful to set up, very easy to set up once done a few times. First, I'm just going to set the years up on the column. So I'm going to say 1, enter, 2, enter. That's all you need for Excel to see the series, which is obviously 1, 2, 3, 4. Actually, sorry, I'm going to start here at 0, 0, 1, 2. Let's do that, 0, 1, 2. Then I'm going to select those 3 cells, and then I'm going to put my cursor on this little item here, which is the fill handle, they call it, and I'm going to click on it. Notice the fill handle can't look like that. It's got to look like this. Click on it, left click, and then drag it on down to 7 periods. Notice the little 7 that pops up, giving us that series of numbers for us, which is a nice, useful tip. And then we're going to go up top, Home tab. I'm going to go to the alignment. I'd like to center those years and have them centered. So I'm going to center them. There we have it. That's just, you don't have to do that, but that's just, I think it looks better. It looks better, so I'm going to do it. So then we want to start off with our investment. Now we're going to assume the investment is $2,000, actually using an investment amount, making it more concrete for us, determine how long it will take for that $2,000 to double, which means it should be $4,000 if it were to double. Obviously, if we were just picking a number and we weren't given a number and we want to figure out how long something would take to double, we might better use like 100 or 1,000 or something like that. But just note that this doubling concept, we can use whatever the investment is because it's going to be the rate that will be the factor to determine how long it will take for it to double. So I'm going to start over here. I'm going to say this equals, I'm not just going to type in 2,000. I'm going to say it equals this 2,000 and then enter. We'll do our calculation. Now, if we did this in a calculator, it would be the 2,000 times 12%. Let's just pull up a trusty calculator. So in the trusty calculator, we just simply have the 2,000 times 0.12, and that would give us the 240 interest for the first year. And so that's going to be our calculation. We'll do that basically here, but once again, I want to use it not hard coding the numbers. I want to use the data so I can copy this thing down into the table. So this is going to be equal to, I'm going to pick up this 2,000 up top. That's why I put period 0, because I don't want to pick it up down here because I would like to copy the table down. And then I'm going to multiply it times this 12%, which is in the format of a decimal. And then I'm going to say enter. So there we have it, 240, 240. Now we might add a couple decimals there just in case there were percentages. There's not here, but there may be in the future if you want to see the pennies. That's in the numbers group, adding a couple pennies. And then we can add this up. We could say, all right, well, that means that we now have what we had at the start, 2,000 starting investment plus the 240, which is going to give us the 2,240. 2,240. You can get to that end number, of course, by taking the 2,000 times the 0.12. There's the 240 plus the 2,000. Or you could say, well, if this is 12%, that's a 100% plus 12%. 1 plus 1.12, which gives us 1.12 or 112% times the 2,000. And that'll also get you to that 2,240. So we'll go ahead and copy this down. But before we do, let's do that same calculation a few more times just to get a feel for it. So now we're going to be here in cell I4, and I'm going to do it again. This equals the 2,240 in cell J3 times the 12%. So J3 times B2, enter. And you could add some decimals there. So now we got a couple decimals, number group, adding a couple decimals. The investment now is where we were before, 2,240 plus the 2680.8, We could add decimals to these three too by going to the number group, add a couple decimals. So there we have that there. We can continue this on down. This equals then the 2508. Now it's compounding 0.8 there on J4 times the 12%. The interest is going up. Now it's at 301. Let's add some decimals. Number group, add a couple decimals. Then we can then say, okay, this is where we were before after period 2, 2508.8 plus the 301.06. Adding a couple decimals, number group, couple decimals, that gets us to the 2809.86. Let's do it one more time. This equals the 2809.86 times the 12%. 12% J5 times B2. Adding a couple decimals, number group, decimals. I call that decimalizing it, which is a made-up number, but I think it's kind of fun to say. Decimalized it. And then we're going to say this is going to be, you probably don't want to say that, professionally, but it's still fun to say. So we're going to say the 2806.89 plus the 337.18. That'll give us this number. We're going to then add a couple decimals. We're at the 31747.04. Now let's do this. I'm going to actually delete what we have done and try to copy this down easily so we can do this and see how fast we can build the table and work on our Excel skills. So I'm actually going to delete these columns. I'm going to recalculate it and think about how we could set this up so we could copy it down. So this calculation, once again, in period 1 was the 2000 times the 12. And this one, once again, was the 2000 plus the 240. So now if I copy these down, one way to think about this is, what if I copy these down? Does it do what I want it to do? If I select those cells and take my autofill handle and drag it down, does it do what I want? This doesn't look right. That 0 doesn't look right. If I double click on it, then it pulled this cell down. And typically, if you have a cell that's outside of your table, meaning it's not in the blue area here, then it's going to be something you're going to have to tell Excel, I don't want you to move that down, by using what we call an absolute reference. This cell is actually doing what we want. This cell is moving down relative. That's actually what we want. And this cell is moving down. So this one is what we want. And you can kind of tell, even though this is more complex, because the two cells involved here are both inside the table. They're not coming from the data set. So it's less likely that I'll have to do anything to them when I copy them down. So what I'm going to do is I'm going to delete these two, and I'm going to fix that one, which is this 12%. I'm going to double click on this item. That 12% is in cell B2, so it's in B2. I'm going to put my cursor in the B2 in that formula. Press F4 on the keyboard. That puts a $sign before the B and the 2, noting that you really only need a mixed reference with $1 but an absolute reference is easier conceptually because it can get a little confusing to know which $signs you need. It's useful to figure out which $sign you need because that gets your Excel skills compounded, it gets you thinking better, but there it is. Now, note also that the $signs have nothing to do with money, by the way. It doesn't have anything to do with money. It's just like a code. It's Excel code, in essence, saying, Excel, do not move this cell down. Do not move the B, the column, or the row down when I copy it. So then we're going to do it again. I'm going to select these two. Sometimes I'll test it if I'm not confident in myself, and I'll put my cursor right here in the autofill and drag it down. Say, does it do what I want to do this time? Double click here. 12 looks right. That number looks right. It does indeed. That B2 stayed the same because it has the $signs. That's exactly what I expected. So that's did and then this one did just what it should. Okay, then let's copy it down. Let's select these two, put our cursor on the fill handle, so it looks like that, and then drag it on down, dragging it on down, and there we have it. So we can see between years 6 and 7, that's when it's going to double, which is what we were looking for, getting from 2000 to the 4000. Now, we could get a little bit more precise and say, well, what would be the fraction of a year and whatnot, and calculate that using this method as well. But for now, I just want to show how to do this running balance to get that estimate or approximation and point out the fact that this gives you a lot more data than just the rule of 72 or even formulas or functions that we can use in Excel, because it not only gives you the end number, meaning just the number of years, around 6 years, right? It gives you actually why. It gives you more detail in terms of the interest that's going to be involved. So the rule of 72, just to recap, if I unhide some cells, I'm going to put my cursor on column B, drag it over to column H, So I'm going to left click on it and drag from B to H so I can unhide these cells. Right click on those cells, unhide them. So the rule of 72 give us around 6. It's actually, that's an estimate, but that's a pretty good estimate, but it's restrictive. Notice that how much more detail you get when you kind of run the table out. Now, the same thing will be true when we go to functions over here. I can use this function in Excel, which we'll do next time, to get the payment, which will get a little bit more exact than the rule of 72, and it can be used to figure out dates that are more than just doubled, right? We can say however long, we can figure different things out rather than just be restricted to a doubling like the rule of 72 is, but it's still restrictive. It'll give us a magic number. So this running table, being able to understand that, put that together, really gets your mind understanding a little bit more on what is going on. So in future presentations, we'll do the same thing with Excel formulas. We will then do mathematical formulas. We'll then consider Excel tables. These are all related concepts when you're thinking about the time value of money, and you want to know at least of all of them so that when people use them, you can follow what they're doing.